So,
All day.
okay, a plus 3 Coulomb charge sits at 0, 0. A minus 2 Coulomb charge sits at 7, 0. Where can you place a plus 8 Coulomb charge to make the net force on the negative 2 Coulomb charge? No way. 0.
I have no idea.
Alright, so here's our plus 3. Here's our minus 2. And our plus 8 Coulomb charge is going to go somewhere. I have no idea where.
On the opposite
So,
side of the negative.
most likely, let's see. The force between these two, is it going to be attractive or repulsive?
Attractive.
Attractive. So if I'm looking at this charge right here, right? That's the one the question's asking about, the minus 2 charge. The force on that guy is going to be this way. Force between the 3 and the 2. It's not a 2, it's an 8. It's the other one. 3 and the 2. Okay? So, the other charge is positive. Where could I possibly place it to get a force that would cancel this one?
On the other side.
Yes, F3, comma 2. Right, on the other side. If I place this plus 8 Coulomb charge here, look, I've got an attractive force between these two, F2, comma 8. Okay? So there's the setup. Now what do I do?
You
Find out where, how?
find the force of between the plus 3 and the negative 2.
Mm-hmm.
And so you have to find the net force going that way. And then you set up the, is that Coulomb's law?
Right.
You set up the Coulomb's law equation for the other side, and you solve to find the distance.
Right. Okay, so what I'm going to do is plug both of these into Coulomb's law. F equals K Q1 Q2 over R squared. All right? Q1 is going to be, let's do these, the 3, 2 one first. So 3 coulombs times 2 coulombs over the distance squared. This guy is at 0, 0. This guy is at 3, 0. So the distance is
7, 0.
3. What? What? Yeah, you're right. 7. 7 squared. Okay. All right. Now this force has to be equal in magnitude to the other force in order for them to cancel. So that has to equal F 2, comma 8. It's a horrible 8. There we go. Okay? Solving for this force, I get K Q1 Q2 over R squared. I don't know what R is. Okay, that's this distance right here. That's R. No idea what R is. That's what I'm solving for. Okay? So if I set these two equations equal, some magical stuff happens. K's cancel. 2's cancel. And I end up with a really, really easy proportion. 3 over 7 squared equals 8 over R squared. Okay? So, let me know what you get for R. Check my directions here. Yeah, I'm okay. Look the other side.
11.4.
11.43? That sounds good. So,
You do 7 squared times 8, and then divide by 3, and take the square root of that.
basically cross multiplying. So multiply both sides by R squared. Multiply both sides by 7 squared. You get 3R squared equals 8 times 7 squared. Divide by 3, square root. So you get, what was it, 11.4?
3, yes.
So there it is. Woo. Careful, Einstein. 11.4 meters. That's our R. Now, the question isn't really specific. If it were asking for a coordinate, what would we have to do?
Figure out that distance from that one.
Look, this guy right here is at 0, 0. Okay? Now, our R that we found is from this guy, which is at 7, 0. So we would have to add 7 to this in order to find our actual coordinate. So it would be 18.4, comma 0. That would be the actual coordinate. All right? Anybody have any questions?
When he's in the lab, the coordinates you actually do in place.
I mean, it's kind of a common sense thing. Anybody have any questions? All right. Next one's fun. Erase, 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 erase.
Do you use those oars for anything? Like, do you actually, the oars?
No, I don't use them for anything. Okay. An electric field has a strength of 300 newtons per coulomb in the positive x direction. So here's our electric field going this way. If a 12 kilogram particle with a charge of 8 millicoulombs is dropped from a height of 14 meters in this electric field, what horizontal distance will it travel before it hits the ground? Do not neglect gravity. Oh, what's going on here?
I hate gravity.
What? It's moving.
It is moving. What am I going to do? Which way does the gravitational field go, by the way? Down, right? If I put a mass in a gravitational field, it will travel down. So gravitational field is that way. What's the value of the gravitational field?
9.81.
9.81. Okay? So we have the electric field 300 to the right and the gravitational field 9.81 down. What can I do with those fields?
Make a diagonal line.
I'm not gonna do any vector stuff because they're different types of fields. One's electric, one's gravitational. So I can't really add them together. What could I get with fields? What other information do I have? I have mass, I have starting height, and charge. Ooh. What can I do with mass and gravitational field and charge and electric field? I can get forces, okay? I can get forces, right? F equals EQ is electric force, EQ, and F equals mg is gravitational force, all right? So I'm going to use those two equations. Value of E is the electric field 300 times the charge 8 millicoulombs. Milli is times 10 to the negative third. Mass, 12 kilograms. Gravity, 9.81. Okay, so there we go. There are two forces. How does that help me any? What can I get from forces that will get me distances?
Are you serious?
We are going to do kinematics. Yes.
Oh my gosh.
Okay?
Get rid of that thing.
It never goes away. We're going to do kinematics. What do I have to get? How do I start doing kinematic stuff from forces? Solve for what?
Velocity.
Not velocity.
Acceleration.
What? Acceleration. Okay? I'm going to solve these forces for acceleration. Okay? Using force equals mass times acceleration. Okay? So set each one of these equal to ma. Ma. Oh, but we know mass, don't we? 12? 12. 12. Now, one thing to notice, okay? What is the direction of the electric force? To the right, right? We have a positive particle. Positive particles go in the direction of the electric field. So the electric force is going to the right, okay? So the acceleration caused by it is totally in the x direction. Acceleration in the x direction. Which way does the gravitational force go?
Down.
Down. So the acceleration from the gravitational force is totally in the y direction.
Is that
Okay?
a 9? 12?
That's an A. This guy right here, A. Okay? So some magical stuff happens. 12s cancel in our gravity equation. We get the acceleration in the y direction is 9.81. Surprise, surprise. Which way? Down. How about the x direction? Somebody solve that for me real quick. 300 times 8e negative 3 divided by 12.
0.2.
Acceleration in the x direction is 0.2 right. 0.2 meters per second squared to the right. Now what?
Now do we make the triangle?
Huh?
Dang it.
Don't have to make the triangle. We're doing kinematics here. Let me remind you of this equation. X equals VIT plus 1/2 AT squared. Okay? We're going to use this equation, and we're going to use it twice. Once for the x direction, once for the y direction. Okay? So let's write out all our stuff for the x direction. Distance in the x direction, that's just x. Okay, that's what we're solving for. That's what the question wants. what horizontal distance will it travel? Equals initial velocity, if it's dropped, initial velocity is 0, plus 1/2, acceleration in the x direction is 0.2, and time, I don't know that either. Uh-oh. One equation, 2 unknowns. Try the y direction. What is the distance that we travel in the y direction?
14.
14 meters, but we drop 14 meters, right? So negative 14 equals 1/2. A, acceleration is going to be negative 9.81 because it's downwards. 81 times t. Okay? So, solve the y direction for time, plug it into the x direction to get distance. Let me know what you get time, let me know what you get distance. Anybody at the time?
1.68.
1.6, good. 68 seconds. 1.68 seconds for time, so it takes 1.68 seconds for it to hit the ground. In that time, how far does it go? So plug this time in here. Square it, multiply it by 0.2, and divide by 2. Or multiply by 0.5. Your choice.
Or multiply time by 0.5.
I get the feeling there's like 2 people, maybe 3, trying to solve it.
Yeah, pretty much.
I'm going to do this on my fingers before you guys do it.
Getting the abacus out.
That's not what I wanted.
28, and then 9.81 is close enough to 10, so 2.8. 2.8 times 0.2.
0.28.
Hmm?
0.28.
Is that what you're getting?
That's what I'm
0.28? 0.28. Good enough for me. 0.28 meters. So, you drop it from 14 meters up, and it lands 0.28 meters to the right of where you dropped it. Not too
Really
far.
anything.
But that makes sense because it's a really, really weak electric field. Okay, 300 newtons per coulomb, not that much. Okay? Anybody have any questions? All right. So, for those of you at home, we're about to work on the review. The review is at the it's on the website. So go home, download it, look at it, go away. Bye.